一张纸。내가 많이 잡으신 거.
Yeah, what's happened to her?
Okay, cool. I think I know everything so far.
Good.
So these we have to know, okay? So we
Okay.
must know these.
Gotta know that.
So there. Okay.
I think I'm okay.
And then the one we really want to talk about is this one. Delete this one. Miss Simpson. Miss Simpson, am I right? Yes or no?
Yes.
Miss Simpson, you cannot see the phone. There you go. Try and give her a little space. Oh, that's a terrible stool. No man, you can't get it. Come, Miss Simpson, come here. Here. Give Can that stool. Come. Well, let's speak of favoritism now, you know. Okay, there. So what we want to speak about finally is this spin at the end. Alright? So, this is the final, this is where we really want to, this is the last thing. We want to really elaborate on this spin. Okay?
Which one?
So, there's a man named Corey. Alright? So that's it. The one we really want to elaborate on. So this spin is where we really want to spend some time. Okay. So you can all see?
Mm-hmm.
Yeah.
So Corey, come right here a minute. Just 1 minute. Just for this time. Here.
Okay.
Jonathan, you can see?
Not doing it.
Yes, wait a while.
Okay.
Just hold it. This is alcohol. Alright. Here's a point. Excellent. Here's a pointer.
Okay.
Right. Three letters have been stripped off. Okay? So this one is 4, 6 between the pons and the pyramid, 7 is the pons and the olive, and 8 is the lateral angle. Alright? Okay? So you see that is the cerebellar tonsil. Okay? Very good. Excellent. That's all. Oh, this here. And that's the inferior cerebellum. Where this spin is, first of all. That's the inferior cerebellar peduncle. Okay? That's the inferior cerebellar peduncle. But before we do any theory, let's just do some more practical. Alright? Let's just do a lot of practical before we do any theory at all. No theory right now. Just practical. Alright? Where's the pin in there? You see there, Mike? There. Mike, where is it in? That's the superior cerebellum. Okay? So there you see, that's the superior cerebellum. Okay, we don't have a problem with that. Okay? What do we observe here? What are all of these fibers crisscrossing? See, a lot of fibers are crisscrossing. Look at that. What are all those fibers that are crisscrossing there?
Transverse pontine fibers.
And those are the transverse pontocerebellar fibers. These fibers that are crisscrossing, and they're crisscrossing where? Where are they crisscrossing in? What part of the brain are they in? Or what part of the pons? What part of the pons? And if you ask Shani, he will tell you the basilar part of the pons. The pons only has two parts. It has a tegmentum and it has a basilar part. And the basilar part contains the pontine nuclei, okay, the pontine nuclei, together with descending fibers, primarily the corticospinal and corticobulbar, and also they are transverse pontocerebellar. Okay, so it's really dealing with descending fibers. So that's the basilar part of the pons. Okay, so we're just looking. Okay, which cranial nerve emerges right here? And this is the D3. Not D3, the andro. The andro right here. I don't know. No. No.
Is it between the cerebellum and pons and
Trigeminal. Okay, so the trigeminal emerges right there between the pons and the middle cerebellar peduncle. Okay, what does the middle cerebellar peduncle contain? Transverse pontocerebellar fibers. Right? Functional significance? Synergy of movement. Okay, synergy of movement. Okay, very good. All right, just reasonable there. All right, so this is the inferior cerebellar peduncle. That's the inferior cerebellar peduncle. Okay. All right, we know that. Okay, and inferior. So we can, whoever wants to look at it can look at it. All right, that's the inferior cerebellar peduncle. All right. What is contained in there? What are the afferents contained in the inferior cerebellar? What's contained in there? So what's contained in there? Posterior spinocerebellar. What else? Olivocerebellar. Vestibulocerebellar. Okay. Isn't that so? The important one is very important one is, maybe the most important is the vestibulocerebellum. Okay? The vestibulocerebellum, which is a part of balance. Okay? Okay? From where the receptors? Semicircular canals, utricle and saccule. Very good. Alright. Now, if we have that specimen there, you can look at it. But if the specimen so we're just looking at things. Alright, we're just looking at things. Okay? Now. There. What is the pin in? Alright. So, wait. Where is actually another vessel?
Sorry, let me just get this real quick.
There. So Shani, what's the pin in? Yes? What's the pin in? Look at it hard. Look at it hard. These are the colliculi, the corpora quadrigemini, so that's below. Alright? And you have a thing under your tongue called the what? What's that thing? Frenulum. So that's the frenulum villi. What arises just in the region? Trochlear. Cranial nerve, 4. 4 what? 4D? 4D. What's 4D? Dr. Thomas is 4D. It's before it emerges, it decussates. Then it is dorsal. Then it is decimated. And then it supplies the only one to supply the extraocular muscles on the dorsal aspect. Very good. So that's cranial nerve 4. Very good. Okay? Just relaxing. Just relaxing. No, you see this thing is just staring me in the face. As I pick it up, it's like a magnet. Just move towards it. You see, Corey? As you see this specimen, immediately. Let me see if Jonathan can read my mind. Jonathan, what's the thing in this thing that's magical? There's something magical there. It's big. And it's in the brainstem.
It's right there.
Well, a little farther out. There.
So, okay.
Yeah.
Okay. Very good. So what is that? Decussation of the superior cerebellar peduncle.
So the one before was...
Very good. So right there in the center, see there, big and bold. So just begging to be asked. So that is the decussation of the superior cerebellar peduncle. Alright? Very good. Alright, and there that is the aqueduct of Sylvius. And there you can see periaqueductal grade. Okay, so that's a periaqueductal grade right there. Now there is a lady here by the name of Miss Allen.
No. She's
Yes,
not here.
she's there. Allen, what do we have here? Jonathan, what's Miss Allen's first name?
Julian.
Julia. Very good.
Where
is that in?
Well, you're in the region of the hippocampus.
Yeah.
And you're coming, okay, so you're going further out.
Yeah.
The parahippocampal area?
I don't know. It's a slope that you slide down on. When you leave the hippocampus, you slide down on a slope.
And
A slippery slope. The what? The subiculum.
Okay.
That is
Is
the
that far out?
subiculum.
Okay.
Okay, that's the subiculum. So once you leave the hippocampus and you go down on that what sort of slope? That slippery slope. That is the subiculum. Okay? What's the blood supply to that area? And that's Julia. What's the
Oh my goodness.
What's the blood supply?
Somebody,
So that's the subiculum. So that's the
I'm gonna
hippocampus.
say posterior cerebral artery.
Posterior cerebral artery. Posterior cerebral artery.
I'm guessing. I don't even know.
Posterior
Very
cerebral.
good. So that area, what's the blood supply to that area?
Anyone?
Say
Since
posterior.
I was thinking posterior cerebral.
Don't think that way.
Say anterior parietal.
And when in doubt, anterior
Think of the blood
choroidal.
supply to the hippocampal formation. Anterior
Anterior
choroidal.
choroidal. Okay.
The blood supply to the hippocampal formation is the whole of that area is what? Anterior choroidal. That anterior choroidal is coming from where? Anterior choroidal is coming from where?
System.
The anterior choroidal is coming from where? From the internal carotid. Very good. Excellent. All right. Okay. All right. No, I'm just looking for one thing. There. See? There's something begging to be asked here. So even when I was thinking to come tonight, that's all that was on my mind. All right. This was on my mind. This. So that's driving. This was on my mind. Even getting ready. That was on my mind. What is that? And that is still Miss Allen. Miss Allen, what is that? Very good. Julian, what is that? Look hard. Let me show these people here. It's a solid structure. It's a solid structure living in which lobe?
The temporal lobes.
It's a solid structure, the amygdala.
Oh, amygdala, yeah.
The amygdala. A solid structure right in the what? In the temporal lobe. And that's the amygdala. Involved with defense and attack. Very good. Involved with defense and attack. Alright? So when anything is perceived that's a threat, and we need to get either fight or flight, we need to immediately send messages to the hypothalamus, the centers of the autonomic nervous system. Which nucleus of the hypothalamus you want to send input to? Anterior, posterior.
Anterior. Posterior.
Anterior.
Anterior.
Anterior. What function is anterior, Corey? Anterior.
The function of the anterior was
Nucleus
Of the thalamus.
of the thalamus.
is it circle? Yes.
Anterior nucleus of the thalamus is parasympathetic or sympathetic?
Para.
Parasympathetic. Right? Alright? Rather than that, so we don't want to get what? Cold. So that will take us to another nerve that we're not interested in. We need what? Fight or flight. So we need to go to the posterior nucleus.
So thalamus or hypothalamus?
No, hypothalamus.
Hypothalamus. Okay.
Did I
Okay,
get
that
thalamus?
makes more sense. Okay, that makes
Hypothalamus.
Hypothalamus. Okay.
What? Hypothalamus. Yes, I know. Sorry. Hypothalamus. Also, the amygdala needs to what? To activate the hypothalamus and to go to the posterior nucleus. So what's the output of the amygdala to the hypothalamus? And one person alone, Leandro. Leandro, how is the amygdala connected to the hypothalamus? Directly. We want a direct Very good. She's hot. She's on the ball. She's ventral amygdala fever pathway. Excellent. Very good, my dear. Very, very good. All right. Very good. Okay. Okay. No. So, Deandra, to keep all those very goods. All right. Tell me two other major outputs of the amygdala.
Stria terminalis.
Okay, the most important one is the stria terminalis. Stria terminalis takes you to where? Septal area. Very good. What else? She's hot if she knows this one.
Diagonal band of broken.
Excellent. The what? Diagonal. See, Jonathan is proud of it. The diagonal band of Broca. Very good. Diagonal band of Broca. Which you take it directly to the septal area. Okay? The main input is coming from which part of the brain? To the amygdala.
To the amygdala?
Yes.
From 40. No.
She's very good, you know. She's very good. Very good. She's very good. Main input. Main input. Main input.
There's a sensory association area.
Yeah, sensory association area. What's lying on the pin? And that's the stria terminalis. See it right there? That's the stria terminalis. Okay? Stria terminalis. See it right here? The stria terminalis is running in between two things. So let's put a pin. A gold pin is this. Alright, and a red, let's use a blue pin. So the stria terminalis is traveling in between these two things. What are those two things, Corey? Caudate nucleus and the thalamus. In which sulcus? The terminal sulcus. Stria terminalis is traveling in which sulcus? The terminal sulcus. Terminal sulcus is occurring between the thalamus and the caudate nucleus. What else travels in that groove? Thalamus triangle. Alright, so that's the caudate nucleus and that's the thalamus, and the red pin is in the stria terminalis. See right now? Yeah, so the caudate nucleus is in blue, blue is the thalamus, and then the blue there is the stria terminalis. Very good. Now this question alone is to one man. That one man would agree is Jonathan. Jonathan, specifically at this point, what type of fibers are occurring specifically there?
Association.
Is it really so?
No.
No,
Right
it's
there,
not.
projection.
Right there. Is it really so?
It's not so.
And if it's not that, then it's commissural.
So these are the commissural fibers, okay? So these are the what? The connections between the two fornices. Very clear. The connection between the two fornices. Alright, and this is known as the hippocampal, the commissure of the hippocampus, right? We have another name, the Lyrida Davidis. These are all names given to it, okay? Very good. Alright, and there we see the fornix coming down, and at this point here, these are in the anterior columns of the fornix. These are the anterior columns of the fornix. There's a lady here by the name of This is very embarrassing, you know. Miss Simpson, what's the name of the young lady to your left?
To your right. To the right. To the right.
Yes, very good. So, what is this here? Simpson? Mr. Simpson, what's this here? Sharon, what is this? Alright, so, hold on. So, you have to go gentle. Alright, so this is this.
Okay.
So if you cut the brain that way, So there, that's there. So the brain is cut like that. See there? So that is the splenium of the corpus callosum. Alright, that's the back end. That's the splenium of the corpus callosum. So that's the frontal lobes, and here these are the occipital lobes. So that's the splenium of the corpus callosum. Alright. So that's the splenium right there, and that's the thalamus. Okay? Alright. And remember the layer on top of the thalamus, what's that called?
Stratum zonale.
Stratum zonale. Okay. Now, Daniel, name me 4 main afferents to this structure. I'm asking that, Daniel. 4 main afferents to this structure. Alright? First of all, what's the function of this structure?
That's the cardiac.
That's a cardiac.
Yeah.
What is it? What does it function? What's the main function? You alone. I know this is not.
Movement, inhibition and disinhibition of movement.
Go ahead. You said something good.
It's part of the basal ganglion system, so I would say inhibition or disinhibition of movement.
Alright, so there you could say therefore it monitors movement while movement occurs to prevent what? Unwanted movement, isn't that so? To a degree also it's involved with the initiation of movement. Alright, because when it is involved with the initiation of movement, because the premotor cortex lights up before the motor. Okay? So it literally warms up the cortex, and then that movement will occur. Okay? So very important. Involved also with automatic movements. Okay? Reasonable? So this is one of the chief structures of the basal ganglia. Caudate nucleus. Alright, the caudate nucleus is a part of what? The striatum. What structures form the striatum?
Caudate and lentiform.
No, that's corpus striatum. Caudate and putamen, also known as the neostriatum. 4 afferents. What are the main 4 afferents? 1, 2, 3, 4. There are about 5. And there may even be more.
Globus pallidus internal.
No, main afferents going to it. Afferents to the caudate. So all of them are going to end with the word striate. So it's doing its major business with the cortex, isn't that so? The frontal cortex. So therefore it has rich reciprocal connections with the frontal cortex. So corticostriate for the dopaminergic material, nigrostriate, alright, thalamostriate, okay, and amygdalostriate. Alright. So the gases then coming from the pars compacta, isn't that so? So that is the nigrostrial tract, and then from the cortex, the corticostriate, okay, reasonable, and the thalamostriate. Thalamostriate from which nuclei of the thalamus?
VA.
Central media.
VA is basal ganglion.
Or the middle finger.
Afferents.
Afferents, intralaminar.
Afferents. Intralaminar nuclei and the dorsomedial. The dorsomedial and the intralaminar nuclei. Alright? The dorsomedial and the intralaminar nuclei. What's the main function of the dorsomedial nucleus? Shane, what's the main function of the dorsomedial nucleus? Main function of the dorsomedial nucleus. It is the integrating center for all, capital all, somatosensory and viscerosensory input. Right? It is the main afferent, the main function is to integrate somatosensory and viscerosensory input. Therefore involved with subjective states of the individual. How you feel about yourself. Alright? And how you feel about yourself has rich connections with this part of the brain. What part of the brain is this? No, this is just alone to one man. Alright? I'm just dealing with one man alone. And that is a man named Shane. Shane, what part of the brain is this here?
Frontal, prefrontal.
That's prefrontal cortex. Alright? So where the major decisions are made are at the level of the prefrontal cortex. The main decisions, right, are made at the level of the what? Prefrontal cortex. The prefrontal cortex has its richest connections with which nucleus? The dorsomedial nucleus. Very good. All right. So we're just relaxing. All right. Okay, now, so we've looked at the amygdala right here. All right, so just to go over it, the main afferents come from an area called entorhinal cortex. Where the main afferents from? The answer? Entorhinal cortex. How do you define the entorhinal cortex? Anterior end, we can say, of the parahippocampal gyrus, we could say that. Right. Okay, so that's the entorhinal cortex. Entorhinal cortex receives its input from where? From where? Where do you think? Just common sense. Where? No, a man holds a knife like that to you, and you just suddenly get shocked. Because it's the amygdala that tells you he's not holding a cotton candy in front of you. Right? He's holding a knife, and that means bad. That's bad business. So the amygdala is getting its input from where? So all the input comes to the anterior end of the parahippocampal gyrus, but from where? Where you saw it. And you know that's a knife, and that's the sensory association cortex. From where? Sensory association cortex. You have visual sensory association cortex, reasonable. You have all types of sensory association cortex. Taste, auditory. You know, you hear a gunshot, blam! Immediately you know that you're not in a good situation at all right? So you react immediately. So the amygdala and all of that detects that this is not a good story at all. Alright? Okay? Alright. So comes from where? The sensory association cortex, then down to the, feeds on to the entorhinal area, and then now to the amygdala, and also to the hippocampus. The entorhinal cortex now will have, what are the major afferents now going to the hippocampus? Main afferents. Main afferents to the hippocampus. Alveolar and perforant pathways. The what? Alveolar and perforant pathways. The what? Alveolar and perforant pathways. Now there's a lady by the name of Deandra. Deandra, what's the arterial blood supply to the parahippocampal gyrus? I don't know. No man, you're going outside. You're outside. I don't know. But you know who knows? What supplies the tentorial surface of the brain? It supplies the entire tentorial surface, okay? So what we're looking at here is orbital surface. Back here is called what? Tentorial. So the entire tentorial surface of the brain is supplied by what? Posterior cerebral. Alright? Posterior cerebral supplies what? Posterior cerebral supplies what? See a man by the name of Andrew Lee. You see that man there, Andrew Lee? Do you see him? Very good. Excellent. Alright, so Andrew, what we're discussing is the amygdala. Alright, because there's a practical exam coming up around the corner. Very good. That is the amygdala. So that must come in the exam. And the amygdala is involved with what? Defense and attack. Alright? And it has afferents, we said, coming from the entorhinal cortex. And that's receiving input from the sensory association. Alright? Okay, so that's common sense. Sensory association cortex feeds onto here through the insula. So the input passes through the insula. Okay? And then now receives there, and then now sends it in its output mainly by how many fibers? How many tracts we said? All starting with the amygdala. About 4, alright. So directly to the hypothalamus, ventral amygdala fugal, stria terminalis to the septal area, Diagonal band of stroker. Broker. Today, I should really have my coffee, you know. The septal area, I'm trying to do it also. This is a new I'm playing, not a good story. Diagonal band of broken. What else? And then know what? Amygdala striate. With the striatum. They are fibers together. We're alright? So that's the amygdala. So there's a man by the name of Andrew. Andrew, what's the arterial blood supply to the amygdala?
What's the what?
So the pin is in there, the amygdala. And that's primarily through the anterior choroidal. Right? So when in doubt, the anterior choroidal. Okay. So there is a man here by the name of Michael. Michael, where's the pin in?
It's a big deal.
Lingual gyros.
So where's the pin in? Go ahead. Mike, what you said?
Say lingual gyros. I'm not sure.
So where's the pin in? The andro.
Say something kilo.
But you're very close. You're hot. So where's the pin? Miss Bromfield?
Say something kilo.
Yeah, but didn't we already ask that?
I don't know.
You know who knows? Jonathan, for sure. Jonathan, where's the pin? No. Harry. That's easy. That's not a rough one.
Because it's beside the
Parahippocampal
hippocampus.
gyrus. What is a man named? Alright, that's the parahippocampal gyrus. Okay, very good. Okay. Alright. So, Deandra, where is the pin here now?
Posterior commissure.
No, this face.
Oh, third ventricle.
That's the third ventricle. Okay, that's the third ventricle. Okay, so this is a lateral wall of the third ventricle here. So if that's a lateral wall of the third ventricle, what's the pin in? If that's a lateral wall of the third ventricle, then what's the pin in?
The thalamus?
I don't know.
Hypothalamus.
That's a hypothalamus. And above it, this big one above it here, that is the thalamus. Right, that's the thalamus, and down here that is the no, stop it now. Soon stop. That is the hypothalamus, and this is the order turn this thing off.
Take it on your ringtone, sir.
No man, no. That's a very good. Soon we are good. It's nothing. And this is what? Oh gosh, it's still right.
The body of the caudate.
So this is what?
The body of the caudate.
That's the body of the caudate nucleus. Is it the one? That's the body of the. That's the body of the caudate nucleus. Okay. This, what is that now? Sandra, where is the pin here?
Insula parietal.
Andrew, where is the pin?
I think so.
No man, I have to turn this thing off. Oh my God, he said no, this is not a good story. Sorry. Too long a ringtone. Or not ringtone, what do you call it? Messages. It's for messages.
I always remember the song is amazing.
It's for messages. Where is it?
Here.
There. Everybody wants to know. Get,
Look, it gets an
what do you call
instrument.
it? BlackBerry and iPhone. I said, no way. No man, then everybody can get in touch with you. Send what emails and messages. No, I rather stay hidden. Very good.
Spooky, sir. Spooky.
Very good. Yes. They want to find you, that's the problem. They want instant response. This, that, and the other.
Yeah.
So that's in the what? Insula. Isn't that so? That's the insula. Okay? So that's an easy one. That's the insula. Okay? And deep to the insula is the extreme capsule, and then the claustrum and the external capsule. What's the blood supply to the insula?
Say anterior, sorry.
There's a man by the name of Zaki. Zaki, what's the blood supply to the insula? Go ahead. The middle cerebral. Isn't that so? The middle cerebral. The middle cerebral enters right there and divides all up. Isn't that so? Alright, very good. Alright. So we see all these things, and we see the putamen, and then we see the pin was in there in one exam. So the hole still there, and that was in the lobus pallidus. Okay? So say right here, out here, that's the putamen, and in here that is the lobus pallidus. Alright. Okay. Now, this question is to a man by the name of J. Mitchell. There, you've read. Very good. That's the J. Mitchell. So let me put it clearly there. Association pathway occurring here.
Superior longitudinal fasciculus.
The man is on the ground. Superior longitudinal fasciculus. That's really good. Superior longitudinal fasciculus. Right here. That's there. Okay. That's the superior longitudinal fasciculus. Sorry. Okay. But I just want to show you things, I could be talking a lot more, but just want to show you things. Okay. Alright, there. Okay, this one is for Corey. Or Miss Bromfield.
There.
Oui. That's a good specimen. Very good.
Yeah, that's good. That should be good, I hope.
Very good. Yeah.
Huh? Yeah, I know. If you can touch him, just touch him. He's shriveled up. He's really shriveled up.
Okay. So, Corey, what's the pinning? That's a strial terminalis. Okay. The strial terminalis. And that's in the foramen of Monroe. Okay, and therefore that's foramen of Monroe. Therefore, this structure here is anterior nucleus of the thalamus. So let's put in the foramen of Monroe, and then now this pearl-colored pin is in the what? Anterior nucleus of the thalamus, right here. There. So you can pass it around. Sorry, sweetheart. That's very good. Excellent. Move on. Let me move on. Sorry.
So, whoa. So white pin is anterior nucleus of the thalamus.
Fornix. Alright, fornix. So right here, that fornix is part of the circle of Papez. Okay? Involved with what? Emotions and memory. Involved with what? Emotional behavior and memory. Okay? That's the fornix. That's a part of the circle of Papez. Now that fornix, as it comes around, there's a lady by the name of Julianne. Julianne, what happens to the fornix right at that point? There. See, it's curving right around. What does fornix mean? An arch. An arch. A fornix is an arch. Okay? Okay, so the fornix arches from the hippocampus coming off. The fornix is really a continuation of what? Which is a continuation of what? Alveus. So the Alveus leads into the fimbria. The fimbria leads into the fornix, the crura of the fornix, then into the body, then into the anterior column. So whatever the hippocampus is receiving, the hippocampus receives everything. The hippocampus receives what? Everything. Because it's involved with memory. So everything must filter through the hippocampus. Everything must filter. Everything we're perceiving must filter through the hippocampus, because that's where memories are made, at the level of the hippocampus. Okay, short-term memories, which are then going to the cortex to be consolidated as long-term memory. Okay, so the hippocampus receives everything, and then now projects primarily by way of the fornix. So one of the largest tracts is the fornix, the major thing. And the fornix, as it arches around, will now divide into what? What is it does business? Wait, 1 second. It comes around and it reaches this point. Just before reaching that structure, it says, hold on, I have to diverge. What is that structure?
The red pin?
Yes, the red pin. What is the red pin in?
Mammillary.
No, Jonathan, no, man.
Sorry, no, I'm lost.
No, man, no. We cannot say that.
Lost.
Can you see that? Chart now?
Jonathan, what is the pin in?
See the
Anterior
anterior
commissure?
It's the anterior commissure.
So I'll slip.
Anterior commissure. Okay? So the fornix, as it's coming around, it does business with the what? With the anterior commissure. Okay? So, Simpson, can I write here? Very good. Alright? So this is the thalamus, and then winding around is the what? The fornix. Okay? And then that fornix now sees a structure called the anterior commissure. Okay, there. Okay, Mr. Simpson is a very neat lady, you have to be very careful. That's called, let me put AC, anterior commissure. This is thalamus. That's fornix. So it comes around, what does it do? It gives rise now to precommissural fibers and postcommissural fibers. Postcommissural fibers really head to the mammillary body. The precommissural fibers head to where? The septal area. So these are called pre-commissural, these are called post. So the post-commissural primarily go to the mammillary body. From the mammillary body we go through the mammillothalamic tract to the anterior nucleus. And from the mammillary body we also go down a pathway called mammillotegmental to the RF, to the reticular formation. So the fornix, which is receiving everything, sends it now to the septal area. Okay? And then septal area, when septal area gets that information, what does septal area do with it? Sends it to the hypothalamus. Septal area will send it to what? Just pull that for me. Septal area will now send it to the hypothalamus via a structure called what?
Medial forebrain bundle.
The hypothalamus via a thing called medial forebrain bundle. To the what? To the hypothalamus. So you see, you're getting all sorts of things happening. Alright? And then now, from the anterior nucleus it will go up to what? Via thalamocortical fibers to which gyrus? Cingulate. To where? To this cingulate gyrus. Okay, so it's synapses at that point. That's the anterior nucleus. Okay? Very good. See? The fornix comes around and divides right to the anterior commissure into precommissural to the septal area and postcommissural to the mammillary body. Mammillary body, to continue the circular process, continues as the mammillothalamic and then thalamocortical to the cingulate gyrus. To get an autonomic response, it goes through the mammillotegmental to the reticular formation. Septal area gets all the information and sends it primarily now to the hypothalamus through a thing called medial forebrain bundle. Very good.
I got it.
Very good. Excellent. Okay? So there's some theory. Very good. Now, listen to me. The hippocampus So we're asking Jonathan another thing. Let's ask Jonathan this question now. Jonathan, the hippocampus sends this information from memory and everything through the fornix, and some of that input ends up at the septal area. But the hippocampus has another route of sending information to the septal area. What's that route? By what route? The hippocampus, which is receiving, we said everything, has another way of sending stuff to the septal area. And what's that pathway?
Diagonal band.
No. Involves grey underwear.
Inducium crucium.
Inducium crucium.
So I never knew what that meant. I just hear you say it and I just absorb it. I don't know what it is.
I just knew
The thing on top of the corpus callosum.
Very good. So that area, the hippocampus and dentate, converge